Okay, so continuing on with our circles today, we are looking at inscribed angles and polygons within our circle. So that just means inscribed just means it's going to be inside of the circle. So all of the points, all the vertices, everything are going to lie on the edge of the circle. So inscribed angles and intercepted arcs. If you have an inscribed angle, it's an angle whose vertex is on the circle and sides contain chords of the circle. So B is our vertex. The angle ABC is our inscribed angle. And then the arc between A and C is our intercepted arc. So this blue arc is that intercepted arc. So we can also say it in terms of angle B intercepts arc AC is another way to say that. Couple of theorems. Theorem 10, the measure of an inscribed angle theorem. The measure of an inscribed angle is half the measure of its intercepted arc. So let's say that this arc AB is 160 degrees. Then that means that the measure of angle ADB is going to be half of that 160 degrees, or 80 degrees. And then theorem 11, inscribed angles of a circle theorem. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. So this angle ADB and this angle ACB intersect the same arc AB. So since they intersect the same arc, if this arc was 80 degrees, then that means that this angle is 40 degrees by theorem 10, and this angle is 40 degrees by theorem 10. So angle ADB and angle ACB have to be congruent to each other. So in 1 through 3, we're finding the measure of either the red angle or the red arc, whichever one we're given. So in number 1, we need to find the measure of angle HGF. So we know that the arc HF is 90 degrees. So the measure of angle HGF has to equal half of that, which means it's going to equal 45 degrees. In number 2, we need to find the measure of arc TV. So we know angle U is 38 degrees. So 38 equals half of that arc TV, which means to get that arc, we got to multiply 38 by 2. So the measure of arc TV is going to be 76 degrees. And then in number 3, we know that angle Y is 72 degrees. So we know this angle here is 72, which means this arc ZW is 2 times that, which would be 144. Angle X intersects that same arc. So angle ZXW is also going to be half of 144, which will equal 72 degrees. Okay, so inscribed polygons are really very similar to inscribed angles. It's just a polygon where all of the vertices are going to be on the circle. So the circle that contains the vertices is called a circumscribed circle. So when we look at our last two theorems. Theorem 12 is the inscribed right triangle theorem, which says if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Also, if one side of an inscribed triangle is the diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is a right angle. So angle B is a right angle, which means AC is the diameter. And then theorem 13, the inscribed quadrilateral theorem. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So that means that angle D plus angle F in that picture would have to add to 180, and angle E plus angle G would have to add to 180. Okay, so in these last three, we're just solving for our variables. So in number 4, we have a triangle inscribed in our circle. And we know that MK is the diameter because it goes through the center, which means that has to be a right triangle. And since it has to be a right triangle, the angle opposite that diameter has to be the right angle, which means that X has to equal 90. And to find Y, we can take that 90 degrees for X and the 40 degrees at angle M and subtract it from 180 to give us 50 degrees for Y. In number 5, we have a quadrilateral inscribed in a circle. And remember, with quadrilaterals, opposite angles have to be supplementary. So X plus 82 has to equal 180. So we're going to subtract 82 to get 98 for X, and Y plus 68 has to equal 180, which is going to give us, when we subtract our 68 from 180, 112 for Y. And then our last one for this section, we have another quadrilateral inscribed, and we know that our opposite sides have to add to 180. So 8x plus 10x has to equal 180. So that gives us 18x. When we divide by 18, we get 10 for x. And then c plus 2c minus 6 equals 180. Combine our like terms to get 3c minus 6 equals 180. I'm going to add my 6. And when I divide by 3, I get 62 for C. If you have questions, let me know. Your homework will be on Big Ideas.